Hi everyone. Today we will discuss about the parallel and series circuit. So first let's know what is parallel circuit. Parallel connection is that when here I have taken the three resistor, this R1, R2, R3 are connected across each other. So this is a parallel connection. One voltage source is connected across these three resistor, and due to this voltage source one current I is flowing through the resistor. One thing we have to remember in the parallel connection is that the voltage across each resistor is same. If we are taking a 5 volt of voltage source, then across R1 we will find 5 volt, across R2 we will find 5 volt, and also across R3 we will get the same 5 volt. It tells us that the voltage across each resistor is 5 volt in the parallel connection, but the total current I is going in this direction and it is dividing into three parts according to our three resistor. In R1 we are getting I1 current, R2 we are getting I2 current, in R3 we are getting I3 current. It means in parallel connection the current is different in each resistor. So if you are finding the total resistance, when your resistors are connected in parallel connection, the total resistance or the equivalent resistance will be 1 by R1 plus 1 by R2 plus 1 by R3. And the total current I is divided into three parts because we have connected three resistor. Then it will be I1 plus I2 plus I3. Then we will get the whole current flowing in the circuit due to this 5 volt. Then for I1, as we know that the formula of current is equal to, that is V by R, then it will be for I1 it will V by R1, because the voltage is same across each resistor, we are taking the same voltage constant. Then for I2 it will be V by R2, and for I3 it will be V plus R3. So this is all about the parallel connection. We have to note one thing, that in parallel connection the voltage across each resistor is same, but the current in every resistor is different. This is the note about the parallel circuit. The second one is the here I have something marked, that is potential difference across each resistor is same, but the current in each resistance is our different. Next is the series circuit. Here I have connected the three resistor, that is back to back and end to end, and one voltage source is also connected, and the current I is flowing through the circuit. So here R1, R2, R3 resistor are connected back to back and end to end. This is the end of R1 resistor and it is connected with the starting point of R2 resistance. And this is the end point of the R2 resistance and it is connected with the starting point of R3 resistance. Okay, this is the negative sign of voltage source which is connected to the end of this resistor. Now the voltage across in series circuit, the voltage across each resistance, that is different. The voltage drop we will get, that is for this resistance, for this resistance we will get the voltage drop is equal to V1 is equal to I into R1, and for V2 is equal to I into R2, and for V3 is equal to I into R3. It means the voltage across the each resistor in the series connection, that is different, but the current, as it is a series connection, our current is flowing through all the resistor and the same amount of current will be flow through the all the resistor, but the voltage amount will be divided according to the resistor. It means the total voltage will be, that is V is equal to V1 plus V2 plus V3, and the voltage drop across each resistor is, for V1 it will be I into R1. Here I is the constant source because it is a series connection and our current is flowing through all the resistor. So here I is the constant, and for different resistance we are multiplying I into R1 for the voltage drop. For V2 it is I into R2, and for V3 it is I into R3. If I are talking about the total resistance, that is RT is equal to R1 plus R2 plus R3. This is the equivalent resistance. In series connection, we add the resistance simply R1 plus R2 plus R3. But when we are adding or when we are finding out the total resistance in the parallel connection, it will be 1 by R1 plus 1 by R2 plus 1 by R3. So what is the same current, that is the same current I is flowing through all the resistor, but the voltage drop across each resistance is different in series connection. So what we learn about this parallel and series connection, that is, in parallel connection the voltage is same across each resistor, but the current is divided into multiple fact. Then but in series connection the voltage across each resistor is different, but the current is same in each resistor.